Distinguished Vice Rector of Research, Dean, Professors, ladies and gentlemen, it's my pleasure to be with you today and talk to you about my research. So be it 6G, AI, eating all domains of human life, robotics, we are on the verge of a creative collision course, and I'll tell you why. So in 1948, Claude Shannon, the father of information theory, wrote a seminal paper articulating 3 levels of communication. Level A, that is, you have a sender and a receiver, so the sender communicates an image to the receiver, and the receiver has to reconstruct the very same image. That's the type of communication we use until today. Level B is about extracting the meaning, the semantics of the data, and then a receiver can decode the meaning and act upon it to solve a task in a desired way, right? So for example, instead of sending the full image, maybe you send the label of the image to the receiver, or you map the image to a prompt, send the prompt to the receiver, and then the receiver can regenerate either the same image or an equivalent image. Right. Now, from a machine learning perspective, we are all familiar with the jaw-dropping performance of large language models and ChatGPT and so on. So this system one-type machine learning are basically learning statistical patterns from data with a lot of data, a lot of compute power, which makes them basically brittle, a lot of energy expenditures, equivalent of many villages around Europe. So they are nothing but a large Excel sheet or large database. Contrast to that, System 2 machine learning, which is the one that humans use on a daily basis, that's the one that learns causal models of the world, allowing you to counterfactually reason, cause and effect, ask the what-if question, essentially like scientists do. Right? That's the machine learning technology we don't have today. And that's why we don't have level 5 autonomous vehicles. So semantic communication and the confluence of semantic communication and System 2 machine learning gives rise to a new research vision of distributed wireless intelligence, essentially based on 3 key pillars. Pillar number 1, abstraction. So that's the ability to learn concepts, representations from data, multimodal data, image, text, video, so on, right? Compositionality, that is the ability to compose 2 concepts and get a new concept, concept red, concept car, you get red car. But you can also emerge resilient systems out of non-resilient components. Number 3, emergence of communication languages, that is the ability to learn new vocabulary, new languages. For example, think about collaborative robots in a factory. Right. So taken together, this vision will not only provide orders of magnitude in terms of capacity, delay, resiliency, energy efficiency, but equally important, it will break silos, current silos we see today, by building bridges between seemingly unrelated disciplines of mathematics, statistics, topology, logic, and in so doing will also help train a new generation of scientists, maybe give rise to new research teams, research groups, and have far-reaching consequences than we see today. Thank you very much.